Hello dear students. Our lesson for today is all about one-dimensional motion. At the end of this lesson, the learners will be able to convert a verbal description of a physical situation involving uniform acceleration in one dimension into a mathematical description. Differentiate average velocity from instantaneous velocity. Recognize whether or not a physical situation involves constant velocity or constant acceleration. Interpret displacement and velocity, respectively, as areas under velocity versus time and acceleration versus time curves. Solve problems involving one-dimensional motion with constant acceleration in contexts. Before we go on, let us talk about displacement. A displacement is a vector whose length is the shortest distance from the initial to the final position of a point P undergoing motion. As you can see on the picture, the blue dashed line representing the distance is the length of the total path traveled from point A to point B, while the green line representing the displacement is a straight line connecting point A and point B. Notice that the displacement is shorter than the distance, and it is always like that. Speed versus velocity. Speed is simply the distance that is traveled per second, while velocity is the distance traveled per second in a specific direction. In this picture, speed is simply the car's speed of 20 meters per second, while velocity is 20 meters per second to the right. Now let us study how their averages are calculated. For the average speed, notice that it is calculated by simply dividing the distance traveled by the total time of travel. On the other hand, to calculate average velocity, instead of taking the total distance traveled, the displacement is used. Let us try solving for the average speed. While on vacation, Lisa Carr traveled a total distance of 440 miles. Her trip took 8 hours. What was her average speed? To compute, we use the formula, average speed is equals distance over time. The total distance she traveled is 440 miles that took 8 hours. Dividing 440 miles by 8 hours, we get 55 miles per hour. The average velocity can also be calculated using positions on a number line. Look at the figure shown. The recorded arrival time and over distance are plotted on the number line. The first distance traveled is at P1, 3 meters, which took 2 seconds. At 10 seconds, the next position is at 5 meters. At 30 seconds, the third position is at 8 meters. At 50 seconds, the position is at 11 meters. And at 300 seconds, the last position is at 20 meters. The average velocity is calculated as the ratio between the displacement and the time interval during the displacement. Say we want to calculate the velocity from P1 to P2. The average velocity between P1 and P2 can be calculated as v sub avenue is equals to delta x over delta t, or the change in position over the change in time. The change in position is calculated as x sub 2 minus x sub 1, over t sub 2 minus t sub 1. Substituting, we put 5 meters minus 3 meters, over 10 seconds minus 2 seconds. We get 0.25 meters per second. Note that although the positive direction is often taken to be the rightward, upward, or eastward, we are free to assign any other direction as a positive direction. However, after the positive direction has been assigned, the opposite direction has to be towards the negative. Let's practice. Solve the speed and velocity. Using the diagram, determine the average speed and the average velocity of the skier during these 3 minutes. To compute for the average speed, remember that we will be taking the total distance traveled. To determine the total distance traveled, let us look at the first change in position, from A to B. From A to B, we add 40 plus 100 plus 40. We get distance traveled from A to B as 180 meters. For the distance BC, we add 40 and 100 to get 140 meters. For distance CD, we get 100 meters. Adding all of them, we get 420 meters total distance traveled. Now substituting 420 meters, we calculate the average speed as 420 meters divided by 3 minutes, we get 140 meters per minute. To compute for the average velocity, we will take the displacement of the skier. His displacement will be the distance from his first position to the last. In this case, from point A to point D. Adding 40 meters and 100 meters, we get his displacement as 140 meters. So, the skier has an average velocity of 140 meters to the right divided by 3 minutes. Which is equals to 46.7 meters per minute to the right. For problem number 2, look at the figure carefully. To get AB, we get the difference of 50 and 15, which is 35. To get BC, we get the difference of 35 and 15, which is 20. And for CD, we get the difference of 35 and -5, which is 40. Calculating the total distance, we simply add AB, BC, and CD, and get 95. Substituting 95, we get the average speed as 95 yards divided by 10 minutes, which is the total time it took for him to reach the last position, we get 9.5 yards per minute. For the average velocity, we will take his displacement for point A to point D. To get the displacement, we will get the difference of 50 and -5. As shown, AD is 55 yards. Substituting 55, we get the average velocity of 5.5 yards per minute to the left. Aside from a number line, displacement along the coordinate x can be graphed as a function of time t. The average velocity from a coordinate x1 to x2 is taken as if the motion is along a straight line between said positions at the given time duration. Hence, the average velocity is geometrically the slope between these positions. Instantaneous velocity, v. It is the slope of the tangent line at a given point. Mathematically, this is the derivative of x with respect to t. Observe the graph below, in which time points in figure 3 left correspond to motion with constant or non-constant velocity, negative or positive constant velocity. Answers. The velocity is non-constant in the time intervals from t0 to t1, and from t2 to t3. The velocity is constant in the time intervals from t1 to t2, and from t3 to t4. The velocity is constant and positive in the time interval from t1 to t2. The velocity is constant and negative in the time interval from t3 to t4. One can derive the displacement based on the expression for the average velocity. From v sub av is equals delta x over delta t, to delta x equals v sub av delta t. Notice that as we graph this, the change in position delta x is the blue shape formed by multiplying the average velocity with the change in time. If there is constant velocity, there also is a varying velocity. For a time-varying velocity, the total displacement can be calculated in a similar manner by summing the rectangular areas defined by small intervals in time and the local average velocity as shown on the figure. As the time interval becomes infinitesimally small, the summation becomes an integral. Thus, the total displacement is the area under the curve of the velocity as a function of time between the time points in question. That's all for the first part of this lesson.